Hi doctor, this video is going to present the CPU and hardware performance benchmarks. We are from group 10 and I'm Jingwen. So this is the content of our slide. For introductions, benchmarking is the most common approach used to evaluate, analyze, and compare the performance of CPU. And we have divided into three benchmarks, which is synthetic benchmarks, real-world benchmark, and application benchmarks. The aim of this project is to compare different computer performance and write an assembly language to execute a program. And we have four objectives. The first one is understand the principles of CPU benchmarking. Second one is compare the performance of different CPU. The third one is analyze the impact of different workloads on CPU performance. The fourth one is learn to use free benchmarking tools and interpret their results. We are compared the four different computer, and these are the specifications for each of the computer. We are using the four different benchmark tools to determine the CPU performance for each of the computer. The first one is CPU-Z, second one is Geekbench, the third one is Minitools, the last one is Task Manager. This is our flowchart about the installations of the four different benchmarking tools and gather specifications of the computers, record the CPU performance from the benchmarking tool. By using a CPU-Z, we compare the four different computers with the five specifications, which are core speed, bus speed, cache, memory, and motherboard. This is a result we get from the CPU-Z.
By using the Geekbench, we can see the result for 5 specifications, which is the topology, base frequency, maximum frequency, single core score, and multi-core score. So this is the result for all the 4 laptops.
For Task Manager in low CPU load, we compare CPU frequency, memory in use compressed, cache memory, disk percentage, and network percentage. For Task Manager in middle CPU load, we compare CPU frequency, memory in use compressed, cache memory, disk percentage, and network percentage. For Task Manager in high CPU load, we compare CPU frequency, memory in use compressed, cache memory, disk percentage, and network percentage among 4 laptops.
So next, we will use Mini tools to do our disk benchmarking, and we found out that HP Pavilion laptop has the best performance in sequential readings of different sizes of data, while Asus VivoBook has the lowest performance. From here, we know that HP Pavilion laptop has the highest speed in sequential writing, while Asus VivoBook has the lowest speed. In random reading, HP Pavilion laptop also has the highest performance. While in random writing, HP Pavilion laptop has the highest speed, while Asus VivoBook has the lowest speed.
By comparing the core speed among the four different computers by using a CPU-Z, we found that Asus VivoBook has the highest core speed, while the Dell Inspiron has the lowest core speed. We can make a conclusion: the higher the core speed, the more the instruction per second they can handle by CPU. The second one is bus speed. We found that Asus VivoBook has the highest bus speed, while the Lenovo IdeaPad 3 has the lowest bus speed. We can make a conclusion that the higher the bus speed, the more the data they can transfer between the CPU and other components. The third one is cache. We have three different cache, which are L1 cache, L2 cache, and L3 cache. We need to compare the four different computers for each cache. So by looking the overall cache, we found that Dell Inspiron has the best performance in overall cache size, while the Lenovo IdeaPad has the poorest performance in overall cache size. So as a conclusion, the higher the cache size, the more data and instruction that can be held and stored. For memory, we found that Dell Inspiron has the highest memory, while the three others computers have the same memory, which category in the low memory. So in this memory, we can conclude that the higher the memory, the higher the rate when accessing the data and perform more efficiently. Next, for motherboard, we found that Dell Inspiron has the best overall motherboard performance due to the large cache and memories, while the Lenovo IdeaPad has the poorest overall motherboard performance. but it can sufficient for the performance everyday's task.
The topology part is focused on the core and traits. So the core is important for the multitasking performance. When the traits is improve the response. So among these four laptops, we can see that the HP Pavilion laptop have the most core and traits. We can say that the HP Pavilion laptop have the more efficient architecture and have the better performance compared with another three laptop. However, the IdeaPad with only two cores and four threads has a lower performance. The base frequency is shows that the ability of the processor whether can process more data and perform more complex tasks in a short time. So the Lenovo IdeaPad have the highest base frequency. It shows that it can process more data and perform more complex tasks in a short time. However, the Asus VivoBook have the lowest base frequency. It need to take longer time than other laptop to process all the data and all the tasks. The maximum frequency is the maximum speed at which the CPU can execute instruction, so it represents the number of cycles per second that the CPU can complete. Based on the Geekbench, we can see that the HP Pavilion laptop have the highest maximum frequency, but the Dell Inspiration laptop have the lowest maximum frequency. OK，就这样。The single core score measures the processing power of one CPU core. We can see that the HP Pavilion laptop have the highest single core score. This means that the laptop will be efficient when you use the application or you perform the complex tasks that mostly depends on the single core. However, the Lenovo IdeaPad have the lowest single core score. It shows that it maybe will be slow or lag when you perform the task and use the application that highly rely on the single core. Okay, now we come to the last part, multi-core score. The multi-core score measures the effectiveness of the application to distribute their instruction between the multiple cores. So the Dell Inspiron laptop has the highest multi-core score. So it shows that it will be fast when running the complex application. However, for the Lenovo laptop, okay, the Lenovo IdeaPad 3 has the lowest multi-core score. It has a limited multi-core processing power, so it will be lagging when you handle the complex tasks.
Let's see the analyst using Task Manager under low CPU load. The Dell Experience leads with 2.18 GHz CPU frequency, 6.7 GB memory usage, and 3.1 GB efficient caching, ensuring superior performance. This is followed by the HP Pavilion and then the Asus VivoBook. The Lenovo IdeaPad 3 with its lower specs may face performance limitations. Under moderate CPU load, the Lenovo IdeaPad 3 leads with its high 2.1 GHz CPU frequency, 2.6 GB caching, and 3.1 GB memory usage, ensuring strong performance. The Dell's Experience and HP Pavilion follows it. However, the Asus VivoBook ranks lowest due to its lower 0.9 GHz CPU frequency. Under high CPU load, the Dell Experience lead with a high CPU frequency of 2.19 GHz, efficient memory usage of 10.8 GB, excellent caching at 3.9 GB, and minimal disk usage at 1%, ensuring strong performance, followed by Lenovo IdeaPad 3 and HP Pavilion. The Asus VivoBook with its lower CPU frequency of 0.82 GHz, moderate memory usage of 5.8 GB, and less efficient caching of 1.9 GB may face challenges with CPU-intensive tasks and slower data retrieval, potentially leading to slower overall performance. The Lenovo IdeaPad 3 initially had high memory usage 92%, which impact performance. Closing unnecessary application reduced memory usage to 56%, improving system responsiveness. CPU usage also decreased to 13%, further enhancing overall performance, especially during multitasking and memory-intensive tasks.
We need tools to test for the sequential reading and writing speed of four different computers, and we can note that HP Pavilion laptop has the best performance, followed by Lenovo, Dell, and the lowest performance is Asus VivoBook. So we can conclude that HP Pavilion laptop has an outstanding performance in transferring large files to and from the external disk, while Asus VivoBook is not suitable for high-demand applications that involve external disks due to its lowest performance. Task we do is random read and write tasks. It is used to measure the ability to handle small data blocks scattered across the external disk. From here, we know that HP Pavilion laptop has the highest performance in it. So it is effective for tasks that require quick access to multiple small files on external disks, while Asus VivoBook has the lowest performance in it. so it is not suitable for multitasking and database management involving the external storage. From this project, we had learned how to use different types of tools like CPU-Z, Geekbench, Windows Task Manager, and mini tools to do different types of benchmarking. This can let us know more about the performance and capability of our computer. Not only that, we also developed an assembly language program to calculate the time taken for executing different loops using the polynomial equations.
Now I would like to demo how to running the CPU-Z. Let's click the CPU-Z. So this is what the CPU-Z look like. We can know the specification of the CPU like the processor, cache, and clock. We also can know the mainboard and memory.
So now I will demo how we run the Geekbench app. So when you open it, we need to click the Run your CPU benchmark here. After that, a result will come out. So here we'll show the system information, include the model, operating system, and the motherboard. After that, this is the CPU information of our laptop. And then this is the memory information. Here is the single core performance. It shows that the application rely on the single core of the CPU. And this one is the multi-core performance. It's the application that rely on multi-core between the CPU. So that's all for the Geekbench demo.
Next, I'm going to do this benchmarking on mini tools. So after we click Start, we can get a result of this, which show the data transfer rate of each sequential reading, sequential writing, and random reading, random writing.
Now I'm going to do demo for Task Manager. First, we can see CPU, memory, disk, and network usage percentage. Next, we can see the CPU frequency, memory in use, and cache memory.
By doing this project, I have gained a lot of knowledge of how to use the different benchmarking tools, and this project improved my analysis skills when collecting the specifications of the laptops.
Through this project, I have learned the importance of doing benchmarking on different laptops. This knowledge is valuable in understanding the capability and limitations of our computer, and this can help me to make informed decisions when it comes to upgrading and optimize my laptop or PC.
So through this project, I have gained my insight into how laptop performance is affected by the factors, and this allows us to apply the knowledge into practical to a real life situation. So I was able to interpret the laptop performance from the report or the summary generated by the benchmarking tools. So this is a very good opportunity to let me learn more and have an understanding about my laptop.
In this project, I learned the basis of CPU benchmarking and its importance in evaluating computer performance. I use tools like CPU-Z, Geekbench, Mini Tools, and Task Manager to compare CPU performance under various workloads. These tools provide insight into hardware specs such as clock speed, cache level, and memory. Now I'm going to do part 2. First, I initialize all the variables that I want, and initialize all the string that I want. After that, I'm going to start debug. First, I am in main loop. Now I'm going to call clear screen. After that, I move the address of welcome to EDX. The address of welcome point to the string that I assigned before. After that, I call write string to display and call carriage return line fit to move the cursor to next line. So after I display the string for requesting number of looping, I can call read in to enter the value that I want. Now I'm going to type 2. After that, I move the new EAX value to max loop, and now I'm going to print another string. Now in line 53, I'm going to call get m seconds to get initial times before loop, and move the EAX value to time 1. Now I'm going to move the max loop to ECX, move 1 to ESI, and move 0 to sum. Now I am in loop L1. So first I'm going to calculate x cubed. Now I'm going to move ESI value to EAX, multiple ESI value with EAX, so I get x squared, and multiple again ESI value with EAX to get x cubed. Now I'm going to calculate a times x cubed, so I multiple the coefficient 1 value with EAX and add the EAX value to sum, so I got new sum value, and now I'm going to move the coefficient 1 value to EAX and call delay. Now in line 73, I'm going to start calculate b times x squared. So I move ESI value to EBX, multiple ESI value with EBX to get x squared, and multiple coefficient 2 value to EBX, and add the EBX value to sum. After that, I move the coefficient 2 value to EAX and call delay. Now I'm going to calculate c times x. So first I move the ESI value to EBX, and I multiply the coefficient 3 value with EBX and add the EBX value to sum. And after that I move the coefficient 3 value to EAX and call delay. Next I move the coefficient 4 value to EAX and add the EAX value to sum, and then I call delay. In line 92, which is loop L1, since my ECX value is 2, so it will going to loop this L1 loop for 2 times. So now the ECX value has become 0, so it exits the loop and go to line 95, which is called get m seconds to get time after calculation. And I move the EAX value to times 2. Now I'm going to print the result. Now in line 106, I move the time 1 value to EAX and call right decimal to print it. And then I move time 2 value to EAX and call right decimal to print it. And next I'm going to calculate the CPU elapsed times. So first I move the time 2 value to EAX and I subtract the time 1 value to EAX. And I move the new EAX value to different time. So now I'm going to print the string first and move the different time value to EAX and call right decimal to print it. And in line 129, I move the sum value to EAX and call right decimal to print. So after I print the string for choose, I can call read character to enter char. So now I'm going to exit, so I enter n. So you can see the AL value is n now. So in line 138, it will compare the AL value with n. Since the AL value is equal to n, so in line 139, it will jump to edit program. So now let's see the line 140, which is compare the AL value with y. Since the AL value is not equal to y, so after that it will not going to jump to main loop. So now let's execute the line 139 first, and it will jump to exit program. And I'm going to print the edit message and exit. That's all from me.